This is Sarah Wilkinson from Humber College and the University of Guelph-Humber. In this video, I'm going to continue my discussion of ATP generating pathways. This one is about anaerobic glycolysis. I would encourage you to visit previous videos to cover the basics before watching this one, and that includes details on enzymes and chemical reactions, what ATP is, other ATP generating pathways such as the phosphogen system, and an introduction to oxidation and reduction reactions. And this would include details about NAD and FAD coenzymes, which I'm going to talk about today. So in this video, I'm going to cover how anaerobic glycolysis produces ATP, so without oxygen. Just a quick disclaimer, I'm not going to cover every single reaction of this pathway, just a general overview. And some of the molecule representations I've given are a little bit simplified. So this is not a detailed look at anaerobic glycolysis, but an overview so you can get a sense of what's going on. So the bottom line in anaerobic glycolysis is this is a series of 10 reactions that takes the molecule glucose, which you'll see here has 6 carbons. So we've got a 6-carbon sugar molecule which is found in the blood. I've drawn that it has oxygen and hydrogen. I haven't drawn the other hydrogens in here because, as you know, remember, carbon forms 4 bonds, so there's a hydrogen on each of these carbons here for simplification purposes. So you got a molecule of glucose, which is 6 carbons, and through a series of 10 chemical reactions, you end up with 2 3-carbon molecules called pyruvate. And so what glycolysis does is it oxidizes glucose. And remember from our previous video, oxidization is the removal, the transfer of electrons and its associated hydrogens to a coenzyme or another molecule. And what this is doing is it's releasing some of the energy found within chemical bonds of glucose to be transferred to coenzymes, which will end up in the electron transport chains. The bottom line is this is a series of 10 reactions that takes a 6-carbon molecule called glucose and turns it into 2-pyruvate. I'm not going to go into detail about how glycogen, which is a chain sugar molecule, storage molecule found in muscle and liver, but note that it is only 9 steps. Okay, so it's going to skip the first one. This is the detailed representation of anaerobic glycolysis, and don't leave me now. I'm just going to talk you through some of the basics. Your textbook will have different pictures, but essentially what I wanted to show you here is that here's our molecule of glucose. Just like I showed you, you've got your 6 carbons with oxygen and hydrogen and other associated hydrogens, of course. And what's going to happen is here you've got a representation of 10 reactions. So each one is going to have an enzyme. So remember, enzymes speed up reactions, lower the activation energy. So what this first one is doing is there's an investment of ATP. So actually, in order to generate ATP, you actually have to invest ATP. So it's kind of like if you're investing in the stock market, you can't get money for free. You have to invest some in order to gain some. And so here, what's going to happen in the first step, there's going to be a phosphorylation of glucose. So very simply, what it's saying here is that on the 6th carbon, so we've got 1, 2, 3, 4, 5, 6 carbon, you're going to have a phosphate group attached to it. So that's all that's happening in the first step. And then there's another series of steps. So the next step, there's another enzyme, and you rearrange those 6 carbons. So it's still fructose 6-phosphate. The phosphate's still on the 6th carbon. This is just a different sugar molecule called fructose. There's another investment of ATP, so you add another phosphate group, and so you note here that it says 1,6 bisphosphate, so 2 phosphates, one on the 1st carbon group and the second on the 6th. And if you know anything about rate-limiting enzymes, this enzyme right here, phosphofructokinase, is the rate-limiting enzyme. That means it's the slowest in the pathway. The next step is taking the 6-carbon molecule, and this is where we end up with our 2 3-carbon molecule. And note from now on in, note this line says times 2 because each one of these molecules goes through these series of steps. so on and so forth. You get some rearrangement, removing of some electrons here. So here's where your NAD becomes reduced. The electrons and hydrogens being donated to your coenzyme. This is where you start to generate ATP in this step, and then you have another one on the last step. And remember, this happens twice. So you get 4 ATP for 2 invested. Not a big bang for your buck, but doubling your money at least. And you can see here that in the last step, okay, we've got all these different steps to get to this, we end up with a molecule of pyruvate. And remember, because this happens twice, 2 molecules of pyruvate. So that's the details of glycolysis. So let's just summarize some of the highlights of anaerobic glycolysis, some of the real key points that you need to know. The first one is that it takes place in the cytosol. If you remember the phosphagen system, what I said about reactions taking place in the cytosol is that means that the ATP can be immediately used, because most cellular activity that requires ATP is going to be taking it right from the cytosol. So your contractile proteins are right there. It's a series of 10 reactions, which means it's going to take a little bit more time to generate ATP than using phosphocreatine, which is 1 reaction. Your glucose is oxidized in those 10 reactions to eventually form 2 3-carbon molecules called pyruvate. And in the process, you end up reducing your coenzyme. So electrons and hydrogens are transferred to the coenzyme NAD, and remember that's transferring some of the energy. That NADH is going to be able to go on, if there's sufficient oxygen, to the electron transport chain. And you end up with a net 2 ATP forms. Remember, an investment of 2, generating 4 minus 2, you end up with net 2 ATP. So not a whole bunch of ATP. If we're talking glycogen, because glycogen enters the pathway after the first step, we're going to generate 1 extra ATP because there's not an investment here. So if you have glycogen coming in, glucose 1-phosphate going to glucose 6-phosphate, you're going to end up generating 1 extra molecule of ATP. So you'll get 3 ATP for glycogen. So far I've covered how ATP can be generated using phosphocreatine as substrate. We've talked about where ATP can be generated using anaerobic glycolysis, so using glucose. The next videos are going to cover oxidative phosphorylation, so the use of oxygen in order to generate ATP.